This is Teacher Mark. Our lesson for today is all about greatest common factor. So before we proceed to our main topic for today, let us review first. Find the prime factorization of the following numbers. 12, which is 12 is 2 times 2 times 3. If you multiply that, if you simplify, example of this is, if you multiply 2 times 2 is 4 and 4 times 3 is 12. Therefore, all of these number are prime number. Therefore, this is the prime factorization of 12. Next, 40. 2 times 2 times 2 times 5, because if you multiply all of this, the answer is 40, and 2 and 5 also is a prime numbers. Next, 56. 2 times 2 times 2 times 7. Again, 2 and 7 are prime numbers. And if you multiply 2 times 2 times 2 is equals to 8. And then times 7, that is 56. 60. Okay? So 60 is 2 times 2 times 3 times 5. If you multiply all of these numbers, 2, 3, and 5 are prime numbers. Therefore, if you multiply those numbers, you get 60. And lastly, 120. 120 is 2 times 2 times 2 times 3 times 5. So if you multiply all these prime numbers, you get 120. Okay? Then, okay? Then, so before we go on, prime factorization has a methods you use. You can use listing factors. You may use a factor tree or the continuous division. Uh, it's up to you how you handle it and how you use it. Okay? Topic for today. Our topic for today is all about greatest common factor, or GCF. So what is the GCF? The GCF of two numbers is the greatest number that is factor of both numbers. So what is relatively prime numbers? If the numbers have 1 as their GCF, for example, if has two numbers that is no, there is no GCF than 1, therefore that's what you call the pair of number, or those numbers has a relatively prime numbers. So these are the ways in getting GCF. First is the listing factors. The second is the prime factors. And the last one is the Euclidean algorithm. I'm giving you an example how to use these three ways or three methods. Okay? So the first method is the using listing factors. In our last grading, I teach you how to get the factors. So you may apply this on this part. So first, find the GCF of 12 and 27. First thing you do is you need to find their factors. Okay, so the factors are 1, 2, 3, 4, 6, 12. Okay, again, so just a review. So if you multiply 1 by 12, that is 12. 2 times 6 is 12. And 3 times 4 is 12. Therefore, these are the factors. And the factors for 27 is 1, 3, 9, 27. So you can see, if you multiply 3 by 9, the answer is 27. As you can see, how do we get the GCF of these two numbers? So as you can see, there is same numbers. You need to locate same numbers aside of 1. Okay? But if there is no number that is the same and only 1, therefore that is relatively prime numbers. But in this case, we have 3. Okay? So the same number is 3. So therefore, 3 is the GCF, or the greatest common factor. Okay? Next, we have find the GCF of 40 and 25. So by the use of factors, listing factors, we list the factors of 40. So the list factors of 40 is 1, 2, 4, 5, 8, 10, 20, and 40. And then in 25, 1, 5, 25 only. So as you can see, again, repeat the instructions. So are the steps. First is look for the listing, the factors. The second one is check the number if they have the same factor. So as you can see here, there is highlighted the same number are 5. Therefore, 5 is the GCF of 40 and 25. Okay, so that is the first method that we need to use in getting or in solving a GCF method. How to use prime factorization in getting GCF. So we all know that prime factorization has lots of methods to get it. But I suggest you need to use the things that you want, the most you admirable or the most easiest for you. But for me, I think the most easiest there is the factor 3. It's up to you. Okay. The important part here is you need to know what is the correct prime factorization or prime factors of this number. So as you can see, we need to find the GCF 12 and 27. So the prime factors are 2 times 2 times 3. Okay. Next, 27 is 3 times 3 times 3. So you may see if you uh, solve 2 times 2 times 3 is 12, and then 3 times 3 times 3 is 27. And all of it is prime factor. Therefore, that is the prime factors. As you can see, there is a highlighted there. Same as the uh, process in listing factor, but here, you need to use the factors, prime factors. So here, as you can see, 3 are only the same number. So that is as 1, so therefore, that is 3. So their common factor, that's what you call common factor. The only common factor here is only 3, so you need to write 3. Therefore, if it is only one common factor, therefore that is their GCF. Okay? It has to be all of them. For example, it has a 3 number here. It should be all of them have the same number. Okay? Next, find the GCF of 40 and 25 using the prime factorization. So first, get the prime factors of the two number. And then second step is locate the same number. So as you can see, only 5 is their common factors. Therefore, you need to write common factors 5. And then therefore, there is again one common factor. Therefore, that is the GCF. Okay? And the lastly, 30 and 45. So first is you need to get the prime factors. So the prime factors of these numbers are this one, as you can see on your screen. So 30 is 2 times 3 times 5, wherein that is 30, and 3 times 3 times 5 is 45. As you can see, there is two common factor. Why, teacher? Because there is two same number. So therefore, you need to write those number that have the same. So, for example, 3, or write it in a common factor, and 5, you write it 5, 1, 5 here. So therefore, if there is two common factor or more than two, you need to multiply them. Get all the product of those common factor and you may get the GCF. Okay? So those are the second ways of how to get the GCF using prime factorization. As you can see, there's a division part there. That's what you call the Euclidean algorithm. So I just need to because this is the for me this is the easiest one, but you need to understand it before you use this. So how do we do it? How do we use this? For example, we have 8 and 12. To order to get this, find first the smallest number and the bigger number. So the smallest number is 8, therefore it will become the divisor, and 12 will become dividend. So again, you need to divide it. 1, 12 divided by 8 is 1, and multiply it, 8, subtract, you get 4. So after that, after there's no number to bring down, therefore, this should be the remainder. But here in Euclidean algorithm, on the next division part, you need to make that remainder will become your new divisor. And then the before divisor, it will become a dividend. As you may see, 8 here, you just put 8 there. Okay? So after that, you divide again. And as long as you need to get a 0. But if there is no, if there is no number that, there is always a remainder until 5 times. Therefore, you need to break it out and then use other ways of getting GCF, because Euclidean algorithm is only used for just 3 to 4 number of the series so that you may get this. So how do we do this? So you may get the last divisor if there is no remainder. Again, you may get the GCF if there is no remainder. So teacher, what is the remainder there? What is the GCF there? The last divisor. Since the last divisor is 4, because we got 0 as a remainder, therefore 4 is the the GCF of 8 and 12. Next, to make it clear, another example is 36 and 24. So again, the bigger number is 36 and 24 is the smallest number. You need to divide. After that, you need to subtract. And then again, 12 will become your divisor, and then your new dividend will become the previous divisor. So as you can see here, you divide and then you got no remainder. Therefore, the last divisor is 12. Therefore, that is the GCF. So from your home, can you try it so that if we have an online class for tomorrow, we can know what is all about here. So you try it at your home. Okay. And then remember, the GCF2 number is the greatest number that is a factor of both number. And relative prime numbers if the numbers have a 1 as their GCF. And last is the ways in getting GCF is listing factors, prime factors, and Euclidean algorithm. For that, thank you and hope you something learned from it. Bye!